Thank you so much for that very kind introduction. I'm absolutely delighted to be here. I first want to thank Dave and Drew for everything they did. I want to thank Teeny for organizing and inviting me. And then I want to give a couple of personal thank yous for work by others in the past that has helped sustain the work that gave rise to today's talk. I know that's a lot of words. It'll make sense by the end of the talk. But I first want to tell you a couple of small stories, because given we study complex systems, we make a big deal of the fact that initial conditions mean everything, right? We talk about how systems starting in initial conditions give rise to different trajectories, but I think it's a rather remarkable phenomenon when systems that have different initial conditions actually converge at a certain point in space and time, because it means something's up. So first I want to tell you a small story about Mike Spivey. Mike and I met each other for the first time completely as strangers. We were in the food line at the Attention and Performance Conference in Munich. I think it was in 2000. And I was just getting my food, and this guy was behind me. And we said hi, and he goes, I said hi. We gave each other our names, and he says, "Oh, I like that paper of yours." And what I have to say is that was the first time a stranger ever told me they liked my work. So thank you very much for that. I can tell he hadn't been paid to say that. There was no political interest. He just liked the work, and that will keep you working for years. It's like scoring a hole-in-one on the golf course. And then another story, Ramesh and I actually met each other as strangers at the University of Connecticut back in '99. I visited to give a talk. And at that time, I was talking about prospective perception, which is something that that crowd very much is into. And someone during my talk said, "Hey, what about consciousness?" And I said, "You guys really want to hear about that?" And they said, "Yeah." I said, "Well, okay." I was at one of these Tucson conferences last spring, and I talked a lot about autocatalytic aboutness. And all I can say is, after I finished my explanation, some of you might know, said something like, "Well, Scotty, you should have kept that idea at Tucson." On the one hand, that's an insult. On the one hand, it was a sincere compliment. But after the talk, I was just talking individual spontaneously, and this young man comes up to me and he says, "You need to write a BBS paper." And that was Ramesh. And I remembered that, and so it's nice to meet you. So, it's Friday night at the Theory of Mind Club. Three very famous icons are busy getting drunk. And they're very upset because what we're telling them in cognitive science is destroying them. So, Pinocchio's issue is freedom, right? And I got no strings to hold me down. Cognitive science is telling us that conscious will is supposed to cause actions. We're finding out that it doesn't. So, conscious will seems to be off the table. And then the Marlboro Man. How does the Marlboro Man know he's independent? Well, because everybody tells him he is. The irony of the Marlboro Man is he doesn't get the irony. And so for him, the self is a lone cognizer. And so when I address this issue of free will, I'll be talking about what it is that we do as psychological systems. When I talk about the self or the lone cognizer, I'll address that in terms of how we do it. And we'll argue that it's an inherently socially emergent phenomenon. And then another big problem is Faust. He's been here for centuries. He's in a state of despair because once we partition knowledge from what organisms are, and we act as if knowledge is something that goes into them, we place huge constraints on what human knowledge can be. And we place huge constraints on what human experience can be, and we place huge constraints on what meaning can be. So I'm going to try to solve the problem of these three guys tonight, as long as they buy me a drink. So the first thing is, what do we do? And this is a child who cannot inhibit her actions in a grocery store because conscious will is a generation of constraint. So what does information processing theory, or that's not information processing theory, but psychology tend to tell us about what we do? Well, when we stopped studying consciousness 100 years ago, because we couldn't see consciousness as a dependent variable, we started studying things we could see. And what we could see were environmental events and resulting muscular contractions. So we generated a science of behaviorism, which was good science, and is still good science, all right? Within that framework then, there were other people who were still studying conscious states, But what they did was study the lawful relationship between physical events outside the system and then psychic events within the system. You discover the correlations between those, and you call it psychophysics. 40s and 50s, people started discovering that we could actually pre-tune our conscious experiences with things like attention, and so we have a field emerged called cognitive psychology. Within this framework, which even though these three groups will argue they're really different from each other, I'd argue they share this common framework for a causal story of how we do what we do. And within that causal story, conscious will becomes something that's trapped in the brain, the self becomes something that's trapped in the brain, and the role that conscious will is supposed to play is to cause our actions. And all of that emerges unintentionally out of this causal structure we've created over the past 100 years. So, conscious will causes actions. However, as David Hume said, maybe conscious will is nothing more than just another moment of perceived correlation. So let's look at a Merced demo to sort of get at what I'm after here. So Merced studied the perception of causality, and he presented people images like this. He did things like manipulate the lag between when the red ball would strike the red ball and when the red ball would strike the blue ball and when the blue ball would take off, and he found that our perception of causality is actually a graded phenomenon. It's not an absolute phenomenon. I can kind of feel like that caused that. And Merced discovered three principles that seem to underlie there you go. That seemed to do a pretty good job of explaining our perception of causality. One was priority. A has to occur before B. The more that A occurs before B, the more we experience A is causing B. Consistency, the more that the resulting event is consistent with the A event, the more we experience causality. So if the red ball hits the blue ball and the blue ball goes down like this, we have less of an experience of causality if the blue ball goes like this. So the consistency between the cause and the effect increases our sense of causality that can cause them. And exclusivity. The fewer A events there are, the more we perceive A causing B. So if you had a bunch of red balls that were coming to collide onto B, you would not experience any one of them as really having a big causal role in the movement of A. What Dan Wagner argued in the late 90s then was maybe our perception of our own causality is susceptible to the same three dimensions. I don't know, maybe the perception of mental causality is sensitive to Merced. That's what I just said, okay? So, what we're going to look for then, in priority, it means that thought should precede action. Consistency means the thoughts are consistent with what actually happens, and exclusivity means that there are fewer possible thoughts that could have caused that outcome. So let's look at some of the research Wagner does to show that our perception of our own causality is just as vulnerable to those three dimensions as our perception of causality outside of us. Oh, what happened there? Okay. Anyway, so in the mid-60s, Kornheimer and Dickey discovered what's called Breysch's potential. It's a premotor negativity in the supplementary motor cortex that begins about a second before you make a voluntary finger tap. So this is kind of cool. It looked as though the brain was getting ready. We sort of had a neurocorrelative volition. And then Libet in the mid-80s found that when you ask people to tell you when they become consciously aware that they're going to make a finger press, it turns out they become consciously aware that they're going to make a finger press about 200 milliseconds before the press. So it looked as though the brain was actually preceding the conscious thought, and that somehow we weren't causing our actions. So this threw the whole issue of free will up in the air where it's been since, because the cause actually seems like it's coming after. And then some other work, exclusivity, Wagner and Fuller, for example. If you have participants make right or left responses on some computer task, and you have a confederate stand behind them and put their fingers just over the subjects, but never touch them, and then after every trial, you ask the subject to indicate how much control they felt they had over the response, it shows you that the data indicate that they give 37% of the influence over the response to the participant, to the confederate who's behind them. Just because there's another possible cause of the action, they experience a decrease in their own agency. Another in terms of consistency, Lander and Roth 75, people feel like they control chance events even if they have a previous experience predicting events. So if you have people who are accurately predicting the roll of dice or accurately predicting a binary event, they come to feel more like they're causing it. Right? So the outcome is more consistent with the prediction or their thought, and therefore they feel like they're causing it. So this implies that Wegner's argument is that conscious will is an illusion, or at least it's an illusion that our conscious thoughts are causing it. Well, soccer referees deal with conscious will every game, right? Because when the hand and the ball come together, that's a problem. And what the soccer referee has to figure out is whether or not that agent pre-specified that contact, or whether that contact was incidental. In European culture, that means everything. In American culture, maybe not so much, but in European culture, conscious will is a big deal. But is there any conscious will being expressed here? If the referee says handball, the answer is yes. The player played the ball, right? But the thing I want to point out is that the agent there in the white shirt is doing many, many things at the same time this might be happening. For example, limb movements are being controlled. The limbs are being put into a particular location. Limb-ball relationship is being controlled. This agent's orientation to gravity is being controlled. All of that is happening simultaneously. So, which is it? Which of the two is culture more likely to refer to as involving conscious will? Action or outcomes? Culture believes conscious will has to do with the relationship between thoughts and outcomes, not thoughts and actions. If there's a murder trial, the first thing you do is make sure that your actions gave rise to that person's death somehow. The second question is whether or not you pre-specified it. And it's that difference that's the big one between manslaughter and life in prison or whatever the ultimate penalty is. So the means isn't the issue for culture. And culture doesn't care if thoughts share an efficient causal relationship with action. Culture cares about agents and outcomes, because agents that produce negative outcomes consistently do damage to the group, right? Well, we talked about that then. You can call that an action, and you can call it the hand-ball relationship an outcome. Sue is correct. Well, let's see what William James had to say. I trust that I have now made clear what that idea of a movement is which must precede it in order that it be voluntary. It is not the thought of the innervation which the movement requires. It is the anticipation of the movement's sensible effects, resident or remote, and sometimes very remote indeed. So what makes an action voluntary is the anticipation of the outcome of the action, not the movement itself. But James gives us this weird little thing at the end here. Sensible effects, resident, remote, sometimes very remote indeed. What I'm going to do is translate it into the different time scales of effects, right? So here's what I mean. Sensible effects just means outcomes. Resident effects mean kinesthetic effects, right? My ability to control configurations among body parts when I walk, swim, and dance. Remote effects, what we call things that happen out in the distant world because of my being there, like keep the car on the road or keep the ball out of the net. I can specify those effects. And very remote indeed is what we call cognitive effects. Things like give a talk at UC Merced University on November 24th, or let's go to the Bahamas, right? Those are effects that we can generate, and we can sense at every level whether or not we've generated those effects. All of those then can be consciously pre-specified. So, it turns out that our brains are perfectly organized to be able to take care of generating expectations and checking to see whether or not they've been executed. But I want to point out a very simple aspect of neural architecture and then try to scale it up. So we have association cortex, or we have motor cortex. Neurons in motor cortex project to spinal cortex, muscles move, feedback from the environment. That takes about a second, right? But it turns out that these motor neurons also project on the cerebellum, and those cerebellar neurons also receive feedback from sensory neurons that innervate the moved effector. What that means is down here in the cerebellum, what you have, I thought I had it right there. Okay, we'll leave it at that. What you have down here is a system such that commands and feedbacks are being sent to the same place. Now, the example I want to use here is an infant trying to learn how to grab a ball, right? So an infant's trying to grab a ball and misses, and does it again and misses. and does it again and misses, until over time it doesn't. As an infant doesn't miss and then grabs the ball over and over, oh, yikes. The neuromuscular regularities that give rise to that achievement come to be recursively burned in the brain zone dynamics. In other words, these cerebellar cortical systems are such that now later, when I'm good at something, I generate motor volleys to propel my hand to reach for the ball. As that's going to the spinal cord, I'm priming cerebellum, and cerebellum is recursively priming motor cortex to generate the next aspect of the action instead of waiting on feedback from the environment. To see this in the wild, just remember the Olympics some years ago when all the women were crashing on the vault. So they would run, they would put their hands and jump, go into the air, and they couldn't put their legs out. They were crashing on their knees, every one of them. Until they tried to figure out what was wrong. What they found is that the vault was 2 centimeters too low. And those 2 centimeters in vault height that they had burned into their brains over thousands and thousands of trials of practice, that 2 centimeters was the time it took to get their legs out, right? So these models are highly robust, but they only work within a certain environmental range of constraint, right? Now, different people have talked about this, what I'll call cerebellar cortical recursion. Kawato, a roboticist, calls it anticipatory motor error. Clark, a philosopher, calls it virtual feedback. And Paulin, a biologist, calls it dynamic state estimation. The reason I've italicized those words is because they are all about the future. All of those words are making the point that this transformation that's going on here is about something that's going to happen. Last 20 years, it's come to understand that almost the entire cortex shares such recursive coupling with the cerebellum, not just the motor cortex. And there's arguments now about whether that's the whole cortex, but most people agree it's the vast majority of the cortex. Now this means at all time scales, language, cognition, perception, action, cortex is being continuously primed by patterns in the past because of its coupling with the cerebellum. Therefore, multi-scale effect prediction is a design principle of the brain. And controlling such effects simultaneously is what we do. All right? So I would argue that what we do is multi-scale effect control, as opposed to perception, action, and cognition. William James, I can dance in the dark, that would be resonant effect. I won't do the Macarena for you, but I could, and I could close my eyes, and it's quite obvious I can control configurations across body parts without a distal world to some extent. I can dance across a well-lit room, which means I can nest my resonant control within a larger distal frame, and I can do the Macarena while I'm controlling my relationship to the table. And as I'm making my way to the table, I can also run a simulation on how cool it would be to do that with a partner. And I can do that all at the same time. So the idea that somehow action waits on perception, cognition waits on action, we're doing all of these things at the same time. So action, then, what we typically call action, I would call just effector control, kinesthetic control, whatever you want to call it. And that's not very theoretically interesting per se, but things start to get a little different when we talk about perception, because we're not talking about perception as input anymore, right? We're talking about perception as what I call a distal effect control, right? And let me explain what that means. So it's become clear over the last 20 years that parts of the brain that we previously thought were just premotor are also visual. So now that when I, quote unquote, I'm exposed to an object in the environment that affords a behavior, my premotor cortex becomes active. It's as if I'm perceiving that object in terms of graspability, one of the types of concepts ecological psychologists use quite a bit. We'll skip that. But what I'm trying to get at here is if we're encountering the world in terms of premotor activation and areas of our cortex are continuously being primed by past, that means that anything that's entering the system, any detection that we do, continuously takes place in a neural context of anticipation. And one of the things, I won't talk about my empirical work today, but one of the points of my empirical work is try to unveil this unconscious multi-scale backdrop of expectation that we continuously generate that affords stimuli the opportunity to be stimulated. Our science has begun with the stimulus and asked how we processed it, and somewhat ignore this backdrop. Let me give you an example of 2 quick examples of the backdrop. So you're at a conference, you're talking to your friend walking down the stairs, and your consciousness is all about what you guys are going to say right now. You know, the conversation going back and forth. And then all of a sudden, you start to fall. You kick your foot out so you don't fall. And the second you started to fall, you became very consciously aware of your foot. But what you became aware of is a discrepancy. What you became aware of is the shock that the floor didn't meet your foot when it was supposed to. In other words, what you come to realize in that moment is that you were unconsciously anticipating a certain foot pressure at a certain moment in space and time that didn't happen. That's an example of this backdrop we constantly generate. We experience the discrepancy between what we're anticipating and what happens. And sometimes we still don't even become aware that we made a major contribution to that experience. Another example. All right, everybody careful, it's a complex demonstration. Every one of you knows exactly what I'm going to say next. Right? Not only were you coupled with me anticipatorily at the level of language, every one of you knew that my hand was going to stop. Every one of you knew that the pitch of my voice was going to reach a certain location. All right? Those are examples of not only me functioning at anticipatorily at all these timescales simultaneously, but as I'll address later in the talk, all of you are coupled with me at those same timescales anticipatorily. Right? And it's this idea of multi-scale perspective coupling that I think is, I'm going to try to scale up to account for everything. Right? So that's a joke. All right, so in terms of what we do, I don't want to talk single loops. Of course, this is obvious to people here. But I want to talk about multi-scale nested loops of work. So that we call action, we can call it proximal effect system. Perception, we can call it a distal effect system. And what we tend to call cognition, I'll just play with language today and call it a virtual effect system. Right? And all of these function all the time simultaneously. They are all intentional because they all entail pre-specification. That's what they do. You are pre-specifying a foot pressure. That's how you know it doesn't happen. And they all involve attention in the sense that attention has to do with the ability of one to constrain the other. All right. So thoughts don't cause, outcomes be efficient cause, thoughts cause actions, outcomes indirectly by constraining lower level systems. And there are very smart people who have made a similar statement. And then priority, consistency, and exclusivity are not reasons to deny conscious will. Rather, they reveal temporal relationships between different levels of event control. All right. So, for example, well, let's just get that out there and I'll move on. So, how do we do it? So, what I've done is try to give you a different causal story for psychological functionality. Instead of talking about perception, action, and cognition, what I'm talking about is multi-scale event control. That's a purely causal story. What I want to do is give you a different causal story about the means by which we generate effect control. So, what I want to first do is reconceptualize the context in which living systems emerged. Usually we begin with the idea that living systems emerged in the physical world and over time developmental properties. And what I want to argue is that living systems emerged in what Odom calls a self-organizing energy transformation context. All right? What does that mean? Self-organizing, I don't need to explain that here. It means what you find in the system emerges spontaneously over time on the properties of that system, okay? Hierarchy. What that means is that lower quality forms of energy, such as raw sunlight or electromagnetic radiation, find themselves captured by more sophisticated forms of energy, which we call plants. They intake, transform, and dissipate that energy, which is itself taken in, transformed, and dissipated by what we would call herbivores, which are then taken in, transformed, and dissipated by what we call carnivores, all right? We all learn that as the web of life in 6th grade, it's all good, but I want to argue that there might be some mileage we can gain of talking about the psychological system as talking about them in terms of these far from equilibrium type systems as opposed to physical mental systems. So I want to point out here, I'm not going to use the words physical or mental anymore. I'm going to see how much mileage I can get out of this framework. So the question is, if you're going to exist in an energy transformation hierarchy, how are you going to stay stable? What do you do to stay stable in such a hierarchy? And theoretical biologist Stuart Kaufman taught us that what we call biological systems are systems that are able to keep themselves stable because the chemical interactions that they entail produce products that are catalysts for that reaction. So in this very simple diagram, chemical A, chemical B interact, produce a product AB, or BA, excuse me. If it turns out that BA is actually a catalyst for the AB reaction, that reaction will produce a product that sustains itself. So it's this idea then that stability, what we call biology, can come to be because it's a self-metabolizing system. It's such that the work, and I mean work in the sense of energy transformation, produces products that actually sustain the work. What I'm going to call self-sustaining work. And what I'm going to do is scale this all the way up. That's going to be the attempt to do so. So, now the emergent systems give rise to new contexts that afford emergence of new systems. So as plants emerge, they provide a context that affords the emergence of herbivores. As herbivores emerge, they give rise to a context that affords the emergence of carnivores. This leads to an idea I like to call the fuel source dictates the consumer. And what I mean by this is if you're going to be a system that sustains itself on the energy encapsulated in a zebra, that means you're going to have to be able to capture the zebra, bring it down, and somehow find a way to release the energy in the zebra. Take all that, put it together, you've got a line, right? It's got a system that can propel itself as a mass toward a specific location, and it can reduce the time scale of the problem from large loping movements to very small scale grappling movements, such at the end, you can consider, if you like, a lion a zebra hunter, or a system that sustains itself on zebras. The point here is that evolution is packing more and more structure, I call more and more constraints, into the structure of these systems. Now, it turns out that these newly emergent systems are themselves autocatalytic or self-sustaining. This is not a new idea, but one of the fun parts of doing this work was finding all these really smart people who said the same thing, but at one scale of work at some point in the 20th century. So Donald Hebb taught us, for example, that neurons that fire together wire together. Well, what we know now is that generating action potentials actually has recursive processes on the genetic work in the nucleus, and that recursively gives rise to synapse formation. What does that mean? It means the work of being a neuron. Generating action potentials gives rise to the generation of synapses, which allow you to keep doing the work of being a neuron, right? So the system is, in a sense, creating outcomes that feed back into the system and allow it to sustain itself. Jerry Edelman took this idea in the late 80s and he used it to apply to the development of neural networks in brains, and argued that neural networks come to be that fire together and help the organism survive. Called that neuronal Darwinism. And then my favorite is actually B.F. Skinner. Because what B.F. Skinner taught us is that behaviors that produce outcomes that are positive are sustained in the system's repertoire. Why? Well, he didn't know, he just called it positive reinforcement, right? But what in fact happens is that when this guy does all this multi-scale work of jumping up in a tree, grabbing an apple and eating it, the moment he as he releases the chemical energy entailed in the apple, he's basically replenishing all the systems that gave rise to the work of grabbing an apple. Now that sounds simple, but my point is, Skinner was talking about self-sustaining work. And then Mark Bickard in 2001 made a case for how these multi-scale transformers are all sort of recursively nested and recursively influenced. Now it turns out that one of the reasons self-sustaining systems have been so successful is because the work they do, not on any intention on their part, but the work they do actually gives rise to sustainment generating contexts. I'll deconstruct it. Ants, for example, find themselves coupled by the generation of pheromone gradients. Now there's no ant there trying to cooperate with any other ant. Ants are simply systems that detect and secrete pheromone. And the pheromone they secrete is contingent upon other factors in the world. So when all the ants take off out of the nest in the morning at 360 degrees, they're all laying down a pheromone gradient. Nobody's trying to, it's just what they do. And what happens is, as one of them gets food and follows the gradient back, they release a different pheromone. And as more ants follow them, that lays down a different gradient. Now what I want to do is talk about that gradient as a context that their collective work has created. They have actually reshaped the context in the way, reshape the context in which they're sustaining themselves, completely outside of any ant awareness. right? My point is these systems are able to sustain themselves over the long haul precisely because this is what they do. The work they do affords coupling, unbeknownst to them. Ants, that is a bird. Chickadees are coupled via the generation of what I call external auditory contexts, or auditory gradients. Now we can call it chirping, and we can say that the one bird is sending information to another. Or we can say that what's happening is their coordination is being meted out by the generation of this auditory context. What do I mean? If a male chickadees fight with each other by interrupting each other's calls. So one will start going toot toot, the other one will just cut him off, right? They don't have to see each other. All of this is being meted out distally by generating calls and filling the space with this auditory gradient. If a female chickadee hears her lover lose, she'll copulate with the other male, never having seen them in the fight. My point is, and we can look at that as information and agents talking to each other, or we can look at it as systems that are generating what I call a sustainment context. All right? So how do we do it? Organisms constitute embodiments of context. The fuel source dictates the consumer. Organisms generate and sustain external contexts that afford coupling simply by being alive. It's what they do. They don't have to try to do it. So, given that others constitute an aspect of the sustained context, self-sustaining systems are naturally and necessarily about others. So, how do we get from ant colonies to flocks of birds to the cultures of line dancing humans? And in addition to the multi-scale cerebellocortical recursion I told you about earlier, it also turns out that we're discovering, as I said, that when you see me act, part of what it means for you to see me act is to activate the cortical areas you would have activated to do the same thing yourself. It turns out that there are multi-scales, what people call mirroring systems. So what we find is PF here in parietal cortex, which when you measure it for an individual actor, becomes active as a part of the pre-tuning of effector dynamics as you reach for an object, or as a chimp reaches for an object. It turns out that this area is also very active while watching another do an action, even if the action has no goal. All right, that sort of indicates that this system is pretty resonant to the movement dynamics of others. And of course, the F5 area we all know about. Turns out that activity in F5 becomes active both during the planning and observation of goals. And what I want to add to that is not only are we just mirroring each other in this sense, but we're doing so prospectively. You give rise to activity in my premotor cortex, I'm priming my cerebellum, and that's going to recursively prime to the point where you all knew where my hand was going to go. You knew where my voice was going to go. You knew where my thoughts were going to go. Rizalai et al. Then talk about this in terms of multi-scale resonance. And they talk about what we would call motor resonance. They call it low-scale resonance or low-level resonance. And what we would call cognitive imitation or something like that, they call high-level resonance. In the sense that here, these two agents aren't necessarily coordinating their limb movements in a synchronized way per se, but they are coordinating their cognitions around this event out in the world, which is a map, right? So perspective resonance leads to seeing others in terms of planning at multiple levels simultaneously. Coupled humans become entrained as they mutually modulate one another's prospective dynamics. We develop the ability to cooperate with each other across increasingly large timescales. And that's the issue. Just as ants can coordinate with each other because they lay down a fairly proximal distal gradient in the immediate environment, you and I become able to coordinate with each other in abstract gradients like tomorrow, next year, 2 years from now. And we develop the ability to create increasingly prospective worlds that are less and less constrained by time and space. I have to get a check on how much time I have because I'm a little...
15.
15, okay.
10, 15.
No, let me, well, all right, that's fine, I'll do that. So I want to argue that humans generate and sustain multi-scale intentional contexts. Some may have a better name for that at some point, but what I want to make the case is what's going on in evolution is the scale up of resonance out of self-generated contexts. Ants find themselves coupled because of the context they created at the chemical level. Birds find themselves coupled in a different medium, i.e. electromagnetic radiation, sound. You and I find ourselves coupled at the speed of light and vision. right? But what's happened is a scale up of the context that we can generate. So staying together. So what I want to do then, yeah, 15 is good. What I want to do is talk about the developmental influence of these contexts that we've created, right? So interactional synchrony is coordinated with later attachment. So if you measure how much an infant synchronizes with a caregiver and follow that up later with attachment measures, you find that those who are doing more synchronizing actually feel better attached to their caregiver. Turns out that this sort of synchrony that goes on between caregivers and infants is inherently enjoyable, and it gives rise to an anticipation of support. We'll talk a little bit more about approach avoidance in a second. And the cool thing is they don't have to be moving the same body part. For example, the rhythmic aspect is maintained, so the caregiver can be speaking words and you find the infant blinking in synchrony, right? Which is kind of consistent with a traveling wave idea, right? There's a wave coming out of the speaker that's resonating in the premotor cortex of the infant, but that wave's coming out in terms of eye blinks as opposed to word construction. Now these interactions, these synchronous interactions, they do not reduce informational uncertainty. It's not a high content sort of interaction, but it does reduce affective uncertainty. And that's very important because that'll shape the approach avoidance response of the kid, right? So the idea is that the resonance of the infant leads to overbearing. What that means is we parents, we spend a lot of time like constraining what our kids can do. We pick them up, we put them in our face, and we go, boo. And this model will predict that what the kid will do is go, boo. They won't speak, they just blink or something comes out of them that resonates with the wave we just generated. But what we kind of missed in the imitation literature is the recursive influence that has on the caregiver then. Because the caregiver is going to resonate as well. So you get boo, boo, boo. And all of a sudden you have this loop of boos going on, and you get what I would call a self-sustaining loop of entrainment. And it's emerging and sustaining itself because it's enjoyable. Now, if you have positive entrainment dynamics going on, this is going to lead to the anticipation or positive approach, right? Infants that are around people that yell at them a lot are not going to expose their resonance systems to that adult. They will avoid them, right? So persistent positive approach leads to increasingly prospective approach. And I want to argue here that social approach, actually going up to someone and talking to them, entails the willing exposure of one's resonance systems to the influence of another. And what we spend our developmental years figuring out who we're going to let influence us and who we're not going to let influence us. And we don't have to do much other than respond to our emotions, right? And I would argue then that this sort of embodied trust, this sort of learned approach is a form of embodied trust. And I make this a big deal because I think the whole conversation on mirror systems has led to a big discussion about, awesome, man, we can resonate to each other. But there are plenty of people we don't want to resonate to. So if it's the case that we are really this resonant, then it becomes paramount that we manage our resonance, that we allow some people in and keep other people out. So then we can start to look at adult life as the management of resonance, right? Until we get so good at it that we just don't find ourselves around people we don't want to resonate to, right? So once this sort of medium is created between the caregiver and infant, data indicate, for example, that objects presented after, objects that are presented to the infant after entrainment episodes with 9-month-olds, you get a larger P300 if that object was presented to the infant while it was with its caregiver as opposed to by itself. So the brain's responsivity to the world is actually being reshaped or shaped as a function of doing it in an enculturated medium or alone. Perhaps infant caregiver entrainment provides a scaffold for learning about the world and future relationships with others, because what do caregivers do? Dog, cat, mean person, right? They go around and you label the world as you have them with you. And I call that collective world building. We can talk about that later. Once they get to about 18 months and you put a couple of these young systems together, they'll start resonating with objects. So an adult's done some great work where she puts kids in a room where they have 10 pairs of identical objects, umbrellas, hats. And what you find is the kids will pick up an umbrella and the other kid will pick up the umbrella. And then they'll swing them around together, and then they'll put them down, they'll put on the hats. They spontaneously take turns being the leader, leading the follower. It turns out by 30 months this falls off and it comes to be replaced by language. So what I would argue is what's happening in our resonance systems, as infants, it's rather small-scale motor type stuff. And then as we get to about 18 months, it becomes more about the world and objects. And then as we become increasingly cognitive, it's more about resonating each other with ideas, such at the point that at 30 months, toys are boring. What we do is we resonate with words. Now this persists into adulthood, into this unconscious resonance dynamic, this medium that's there that we just don't talk about. For example, plenty of research shown that pairs of rockers rock in synchrony when they look at each other, even if one chair requires more force. And no one tells the person, you've got more force than the other. They just end up being in synchrony. People that watch the same movie, their cortexes are actually in synchrony in particular places as a function of certain points of the scene. Subtle adult entrainment. The chameleon effect, Chartrand and Barr's data show that people that unconsciously mimic you, you like them more. You have no idea why you like them more. The dark side of all this, Lake and Chartrand and Arkin, fantastic study in 2008. They ostracized people. And then what they did was put them around the people that had ostracized them. And what they found was that people were more likely to unconsciously mimic people who had ostracized them. So it's as if the system has a social recovery device in it that we aren't even consciously aware of. That's the dark side of Maslow's hierarchy, right? So just putting this all into motion a little bit. So caveman comes home from hunting, he says to his wife, I didn't actually catch anything, but I do feel I gained some valuable experience. Now, I'm wondering if it's just another excuse, but look, when that guy's out there tooling around in the world, walking over hills over and over every day, the neurodynamics of that work, the regularities in that work of having a body, generating persistent effects with it over and over, i.e. going through that valley, going over that hill, that gets burned into his neuroarchitecture. And then, just like ants can generate pheromone gradients, you and I can externalize aspects of this stuff that's been embodied. We start putting it out into the world, and it affords us the ability to sort of cooperate with each other in imagination, just like objects afford kids the ability to cooperate with each other in terms of objects. And then you put this all in motion. The cave painting ends up on the ceiling. In 10,000 years, everything blows up to the point where we're in virtual reality. So I just want to give you a brief history of prospective wildness. So at some point, it was worth your time to chase. At some point, it was more worth your time to run away. And that's because you had come to embody the dynamics of the hunt, such that now you ran them towards the edge of the mountain, so they ran off on their own, much less dangerous. That gives rise to that kind of externalization. And then over some thousands of years, we start filling the world with this as opposed to this. But the thing I want to make clear is once we fill the world with this, we have to make this to hold this, and we have to make this to afford us the ability to get to that. So our world starts to look more like what we need to do to be able to cooperate with each other at these increasingly abstract levels. Then I guess we need cars to get to the library. Now we need all kinds of signs, maps for kids, maps for cities, and then everything, people get together and they have chats about how all this happened, and then you have cartoons and Monty Python, and everything is as it should be. So what I want to point is these external contexts, they become increasingly virtual. By virtual, I do not mean unreal, I mean something like abstract. And here's how weirdly abstract they are. They become about the couplings we humans can potentially generate and sustain. They're not about any one person. They are about any particular person. An alien could sort of reverse engineer what we're about just by looking at our architecture, which is what archaeologists do all the time, right? We're going to reverse engineer these people by looking at the way they organize their world. What I want to make clear is that these are necessary to human life because they scaffold our ability to code switch between roles. In other words, different buildings are set up in different ways to afford me to be different people at different times. So this room is situated for me to be able to be a speaker right now. If I go to a restaurant tonight, the place will be set up for me to be a customer. And then if I go to the liquor store later, the place will be set up for me to be a customer again. And so we have to fill our world with these structures that afford us these. And I have to be able, by the way, to competently switch back and forth between these roles, right? Between being a speaker, a customer, etc. So we have been living in virtual reality much longer than we realize. And while that's a play on words, I would argue that the things we call virtual reality are in no way unreal. they are an increase or a decrease in the spatial-temporal constraints of human cooperation. Time and space are becoming increasingly irrelevant to our ability to coordinate ourselves. So, oh, this is great. So why does it have meaning? That's the third part. Well, I guess you can see these people down here. This is a mural painted on a building in my town. This gentleman here, Joel Bergner, is the son of one of my colleagues. And he came to town, he's an international mural artist, and what he does is he goes into a town and he coordinates people's efforts over a week or two to generate one of these things. These kids were high school kids that were at a school for kids who were having trouble in school. And what they did was collectively rearrange the world in a way that these kids can't forget. Every day they go to school, they see that. And I would argue if they see that, it primes them for the kind of things they were doing when they were here, right? So why is it that this multi-scale self-sustaining work has meaning? I would argue that the emergence of self-sustaining systems required the contingent larger scale context of a stable fuel source. In other words, in the prebiotic soup, yeah, you could have autocatalytic systems emerge, but there had to be a larger scale distribution of chemicals available as a fuel source. That means that these single cell systems can be conceptualized as embodiments of these multi-scale contingent constraints. And this is the more philosophical point I want to try to make today. Self-sustaining systems are embodiments of the context from which they emerged and in which they sustain themselves. They can be modeled as embodied context. So if you're going to ask me, what are you, Scott? I'm not going to say I'm a physical mental system. I'm going to say I'm an embodied context. And I don't think it's at all incoherent or inconsistent with any form of science. But my point is by using this way of thinking about organisms, it becomes clear that they are naturally and necessarily about the context they embody. The stuff that's going on inside of me is naturally and necessarily about what's outside of me because it evolved within the context of that which is outside of me. Then this is my take-home point for psychology. There is no epistemic divide between an organism and its context. The internal processes are naturally and necessarily about what's outside of me. When we conceptualize ourselves as physical systems at the turn of the 20th century to fight off certain forms of philosophy, that made sense. But what we did was come to brand ourselves as physical systems. Now this is fine until you try to get phenomena like meaning, value, aesthetics, and consciousness back into our description of what we are. And these arguments never work. Because once you begin with the idea that I'm a physical system, then causality is going to be meted out in the name of physical systems. And you're never going to call me an ontologically meaningful system. Meaning is always something that's going to have to emerge out of some relation I have with the world. And that's the tack that many schools have taken. The organism is a physical system, but since it shares a relation with the world, that relation is the meaning. I would argue, show me a part of an organism that is not inherently relational. Right? And the reason I call organisms embodied context is to continuously draw attention to the relationality that is what organisms are. So, as self-sustaining systems, well, I guess I didn't finish that sentence. They can be modeled as embodied context. I said that they are natural. I said that already. What the heck is that? So let me stop here. So what do? We control multiple events in multiple timescales simultaneously. The concepts perception, action, and cognition may no longer be sufficient to deal with the regularities we are discovering and attempting to conceptualize. Now this is the one place in this country I could say this, and I think it really makes sense. And what I mean is, when you're studying multi-scale systems, you can't think that your analysis is going to be stuck at one level. You can't think that that one level is going to give you the scientific explanation of the phenomenon. So what I'm saying is these concepts, they just aren't sophisticated enough to deal with the multi-scale contingencies you guys are discovering every time you do a project with multi-scale, maybe model it in a multi-scale way. How do we do it? We are able to sustain effects at multiple timescales simultaneously because the very dynamics by which we do so are themselves self-sustaining. Why does that mean? Self-sustaining systems are naturally and necessarily embodiments of context. And what I want to argue is they are knowledge. Knowledge is not something we bring into us. Knowledge is something that we are. They do not need to be informed by the environment in order to be about the environment, for they are embodiments of that environment. I know I'm sounding a bit Buddhist here, but that's the way you need to talk if you're going to try to get out of certain physical mental dichotomies. The environment can modulate what an organism is about, but it does not imbue an organism with meaning, because the organism is meaning. So worlds modulate what organisms are about, and organisms modulate what worlds are about, but it's all meaning from top to bottom. So given their sustainment requires a generation and sustainment of external contexts, pheromone context, auditory context, intentional context, these external contexts are constitutive of multi-scale sustainment. They're not something that we do to survive, they're something that we are to survive. As a result, the anatomy of multi-scale sustainment spreads out across these internal-external couplings, the anatomy of human intelligence, cognition, whatever you want to call it, conceptualized, like spreads out across these other relative intentional contexts groups are able to sustain and generate. And I argue finally by approaching psychological functionality in terms of the homology of self-sustaining work that extends across the levels of scale investigated by chemists, biologists, psychologists, anthropologists, archaeologists. What I call here wild systems theory might be particularly well suited to serve as an integrative, interdisciplinary framework for cognitive science. I'm going to skip, I'm good. This is my last slide. So I'm going to come back to these guys and solve their problems. Pinocchio, I got no strings to hold me down. Freedom is a gradient of constraint, ranging from proximal to distal to the virtual strings of social constraint. In other words, freedom has to do with how abstract your constraints are. If you've got a wall keeping you from leaving a room, that's a fairly proximal constraint. But if you've got an idea constraining you from harming anyone, that's a much more abstract constraint. So everyone is constrained forever. The issue is how abstract are your constraints. Conscious will also does not cause actions, it constrains the ends towards which action systems are directed. In terms of Faust, the mind is a self-sustaining energy transformation system. The mind is of nature, organisms are knowledge. It was our partitioning of knowledge from our ontology of the system, i.e. physical systems, that led us to these, what are they called? The big problem? What's that?
Hard.
The hard problem, right. The hard problem is getting over physicalism. I'm sorry. Anyway, I know I'm independent because I tell everyone I am. The self is a necessary cognitive border. Just as a single cell needs a border to keep parts of the world out, you as a system that deals with abstract relationships all the time needs a border. So you can tell which ideas are yours and which aren't. If you can't do that, you're called schizophrenic. Right? Every one of you has two ideas in your head at least right now. The one you're having and the one I'm putting in there. And you can tell the difference. That border is necessary for you to stay afloat in a world of ideas. If you can't do that, you can't swim. So I would argue then, given that this self emerges out of our persistent approach avoid responses over our developmental life course, the self is actually sort of an embodied other. I'll leave it at that. Thank you.